All right, so I think this is recording. Let's take a look here at number 6. We have two rational expressions. We're dividing them. They want us to simplify this and write it as a single rational expression and also state any restrictions. So with division, you have to be very careful. There's actually going to be two places through our solution that we have to slow down and write our restrictions. Notice that both of our denominators here are the same. Let's come over and start off by factoring our denominator. I'm going to rewrite 40 as 8 times 5. And now if you look at both terms, it's easy to see that 8 is common to both terms. If I factor out that 8, then in the first term I'll have an r, and in the second term I'll have that 5, and of course it stays subtraction. So if we come back to our problem, let's rewrite our denominators. And now it's much easier to see one of our restrictions here and when they're talking about restrictions in arithmetic, we can't divide by 0. Division by 0 is undefined, which means a denominator can never equal 0. Now, there's another common restriction in arithmetic, and that's if you're taking square roots, that if you're working with real numbers, you want to take the square root, avoid negative numbers. Well, we don't have any square roots here, so we don't have to worry about that. But we do have variables in a denominator, so we have to be concerned about division by 0. So 5 minus 5, it's easy to see, would give me 0. And 8 times 0 is, of course, 0. We want to avoid that. We want to tell people that r cannot equal 5. All right, so now we're going to take this division problem and turn it into a multiplication problem similar to our previous couple worksheets. And we can do that if division is the same thing as multiplying by the reciprocal. Now the reciprocal is just the mathematician's fancy way of saying flip this fraction. Flip my divisor. We never do it on the first fraction, but when you change this division to multiplication, you flip this divisor. You flip this second fraction. And so now we have a new denominator. And sometimes that'll cause an additional restriction. This time it doesn't, because we don't have it doesn't introduce a variable in our denominator. So we still have the same old r is greater than 5. But at that point, when you flip it, sometimes you have to add more restrictions. Now, I've got two fractions, and I can write it as a single fraction. If I just multiply the two numerators together, and if I multiply the two denominators together. And it's very easy to multiply by 1, right? And don't forget our restriction. So now as a single fraction, I look and say, well, I've got an 8 divided by 8. That gives me a 1. I've got an r minus 5 divided by r minus 5, and that gives me a 1. So 7 divided by 1 is just 7. So this division problem reduces to 7 provided that r is not equal to 5, because it'll never reduce to 7 if r is equal to 5. It'll just be an undefined expression. That's our final answer. All right, well, I hope that helps. Don't be afraid to ask questions, and I'll talk to you later. Bye.